All right, so I set both of these up on their sides so that the base is not the bottom. And I did that intentionally to force you to look for the base. So number one here, remember the base is the shape that can be pulled through the object, that is used to create the object. And that would be the triangle here. I take that triangle, we're talking about sliding it through cookie dough or whatever. That's the shape that cookie cutter would have to be to cut that object out. So that triangle is my base. So the first step in finding volume or surface area, but we're finding volume first for part A. The first step is to find the area of the base. Since that is a triangle, its area is 8 inches by 15 inches divided by 2, or 60 square inches. So the volume, remember, is the area of the base times the height. So the area of the base here is 60 square inches times the height of 20 inches, which is going to be 1,200. Square inches times inches is inches cubed. That's the volume. For surface area, but we already have the area of the base. That's 60 square inches. I'm writing it down twice because there's one on front and there's one on back. The other piece we need to find then is the lateral area. Or the lateral area is the area of those surfaces, usually rectangles, that connect the bases. And there's two things we need to know to find lateral area. One is the perimeter of the base. Well, the perimeter of the base is found by just adding together the sides of the base. But in this case here, I know the 8 inches, I know the 15 inches, I do not know this side here. For this shape, however, that's a right triangle. So I can find that side by doing a squared plus b squared equals c squared. Very good. So 8 squared plus 15 squared equals c squared. This is 64 plus 225, which is 289, equals c squared. Taking the square root of that, that's got to be 17 inches. So that perimeter of the base, 8 inches plus 15 inches plus 17 inches, which is 40 inches. So next, the second thing we need to know is the height or the distance, and that is the 20 inches. We already have that. So we can go ahead and find our lateral area, which is the perimeter of the base, 40 inches, times the height of 20 inches. This is going to be 800 inches squared. So we simply add together those three. It's 40? That's from 8 plus 15 plus 17, the perimeter of the base. So we have total surface area of 920 square inches. Morning. For the second one here, for volume, I again, the first thing we have to find is the area of the base. This base is a circle, diameter of 8, so a radius of 4. So that's pi times 4 squared. If I'm using 3.14 for pi, that's 50.24 inches squared. So then the volume is the area of the base, 50.24 inches squared, times that height of 10 inches. 502.4 inches cubed. So there's the volume. For the surface area, part B, I need to know the area of the base, which I already have, which is 50.24. And again, there's one on both ends, so I'm going to write that down twice. So 50.24 square inches. Then I have to find the lateral area. For the lateral area, again, I need to know the perimeter of the base. Since the base is a circle, that becomes the circumference of a circle, which is just going to be pi times that diameter of 8 inches, which would be 25.12 inches. So then the lateral area itself is the perimeter of that base, 25.12 inches, times that height of 10 inches. So 251.2 inches squared. And again, we just add those three up. So it becomes 351.68 inches squared. Oh, sure, hold on for a second. These are still giving you a hard time? Then we did some like this. Pyramids and cones. I split that up. I used to do pyramids and cones and spheres. And I had like 3 semesters in a row where the class yelled, "Oh my." And it's like, okay, we won't do that anymore. So let's start out with the cone. Volume and surface area. Well, again, to start out the volume, we still need to know the area of the base. Well, the base of this is a circle with a diameter of 10, so it's a radius of 5. So that area is pi times 5 squared, or 78.5 square inches. My volume is then the area of that base, 78.5 square inches, times my height of 12 inches, But since it's a cone or a pyramid, we divide by 3. Which is 314 cubic inches, the volume. Surface area. We still need the area of the base. Notice I only wrote it down once, though, because there was only one base on a cone. There isn't one on the other end. For lateral area, I need to know 2 things. One is the perimeter of the base. Since this is a cone, the base is a circle, so the perimeter of the base is going to be circumference. So it's going to be pi times that diameter of 10 inches, otherwise known as 31.4 inches. The second thing I need to know that I didn't need to know before is something called the slant, which is capital S. The slant, remember, since these sides don't go straight up anymore, it's the length of the side here, the slant. To find that, I draw in this triangle here. I have the 5 for the radius, this is the height, and this is a right angle. So that slant is going to be found by doing 12 squared plus 5 squared equals that slant squared. So 144 plus 25 equals that slant squared. 169 equals the slant squared. Square root. The slant is 13 inches. So my lateral area is the perimeter of the base times the slant divided by 2 for a cone. So that's the 31.4 inches times the slant of 13 inches divided by 2. This is 204.1 square inches. So I'm just going to add those 2 together now. So it's going to become 282.6 inches squared. That's the surface area. So for the pyramid, volume. Again, we start out with the area of the base. In this case, that's 16 inches times 16 inches, or 256 square inches. So that the volume is the area of that base, 256 inches squared, times the height of 15 inches, divided by 3 again, since it's a pyramid. Which is 1,280 inches cubed. For surface area, again, we start out with the area of the base, which is the 256. Again, there's only one base here, so I'm going to only write it down once. Then I look at the lateral area. For lateral area, I need to know the perimeter of the base, which is just 16 inches plus 16 inches plus 16 inches plus 16 inches, or 16 times 4, which is 64 inches is the perimeter of my base. I also need to know the slant. So I'm going to go up here. If I draw the height down from the peak, it should hit square in the center of that. That's 15 inches. Then from there over, should be half of the side. That should be 8 inches. So the slant is this length down here, which is the hypotenuse. So that's going to be 15 squared plus 8 squared equals that slant squared. So 225 plus 64, which is 289, equals that slant squared. So we square root that slant is 17 inches. So the lateral surface area, lateral area, it's the perimeter of the base, 64 inches, times the slant of 17 inches, divided by 2 since they form triangles now instead of rectangles. So that ends up being, what, 544 inches squared. Adds up to a total surface area of exactly 800 inches squared. Morning. Any questions on that one? All of it? You getting any better or no? I hear you. The hamster hasn't quite got on the wheel for me yet either. So here I have a sphere with a 6-foot radius. If you recall, the volume of a sphere is 4/3 times pi times the radius cubed. So for this problem, that's 4/3 times pi times 6 cubed, or 6 to the 3rd power. So I type that in as 4 divided by 3 times, I'm going to type in 3.14 for pi, times 6 caret key 3 to the power of 3. 904.32. And that is going to be cubic feet, since that was in feet. Surface area is 4 times pi times radius squared. So those are two formulas you're just going to have written down somewhere. So the surface area of this shape is 4 times pi times 6 squared. If I type that in, I'm going to get 452.16, I believe, square feet. It's Monday, so we're going to try it. And it is 452.16. Another very important concept for us in geometry is being able to take a shape and either enlarge or reduce it. So I'm going to take this shape here. I'm going to enlarge it. Get back here. There, I've enlarged it. And let's say the original shape here had sides of 8 inches, 12 inches, and 14 inches. Now you watched me enlarge this, so you know that the two shapes are sitting in the same orientation. But normally I would have to verify what corners, what sides go with which sides. And I do that by looking at the angles. If I tell you that this angle and this angle are the same, and if I tell you this angle and this angle are the same, the third angle then has to be the same, because remember, a triangle has to add up to 180. So the third angle is already determined once you know the first two. So that tells us that these two triangles are sitting in the same orientation. And it also tells us that the big one is an enlargement of the small one. If the angles are the same, they have to be what we refer to as similar figures. So again, similar figures means one has just been enlarged or reduced from the other one. So if I tell you that this side here is 20 inches, we can now find the other sides. The reason we can do that is because there's an enlargement factor. Every side over here had to be multiplied by the same number to get the sides over here. It's what we call direct variation, or proportional. And in similar figures, the sides must be proportional. So we start out by taking the two sides that are corresponding. Now, what do I mean by corresponding? Like side 8 here corresponds to the 20. The 12 here corresponds to the x. 14 here corresponds to the y. What makes them corresponding? Well, they're the same side. It's just one is before the enlargement, one's after the enlargement. The 8-inch side became the 20-inch side when we enlarged it. The 12-inch side became the X side when we enlarged it, and so on. So those are what we call corresponding sides. What we have to do is we have to find corresponding sides where we know both the before and the after. We know that corresponding side in both figures. And in here, that's the 8 inches and the 20 inches. So that is our first ratio in our proportion. We know that 8 became 20. Now let's say that we decide we're going to find side x here first. X has to go in the other ratio. We have to figure out whether x has to go on top or bottom. And we do that by looking at which figure it came from. X comes from the same figure as the 20. So it has to match up with the 20. So 20 is on bottom, X goes on bottom. What's going to have to go above the X? Well, its corresponding side is 12. I don't necessarily have to have the inches in here, but I did it just for consistency. So 20 times 12 is 240. 20 inches times 12 inches, 240 inches squared. Divided by 8 inches. Well, 240 divided by 8 is 30. Square inches divided by inches is just inches. So X is 30 inches. I find Y exactly the same way. So I still have 8 inches became 20 inches. Does Y go on top or bottom? Still from the same figure as the 20, so it still goes on bottom. And its corresponding side? The 14. So again, we will cross multiply and divide. 20 times 14 is 280. Inches times inches is inches squared. Divided by 8. It's going to be 35 square inches. So Y is 35 inches squared. Any questions? Okay. Oh, it shouldn't be squared. You're right. It should be just inches. Good point. That was just me being half asleep yet for the morning. Good catch. Now, not all figures are going to be set lined up the same way like that. For example, we might have one like this. That's what they pay me for. I'm going to tell you, this angle and this angle are the same. This angle and this angle are the same. So we know they're similar. This side here, let's say, is 4 inches. And let's say this side here is 10 inches. And this one we're going to call X. Over here, we're going to call this side here 14 inches. This side we're going to call Y. And this side's going to be 35 inches. Actually, can't make that 35 inches. Let me double check that. Let's make that one 42 inches. I'll be a little more consistent that way. Sometimes it helps to match up the corresponding sides. So the 42 corresponds to what side in the other figure? X. Now, if you're wondering, how do I know that? Well, because the 42 is between this angle with a single mark and the unmarked angle. Over here, here's the single mark and the unmarked angle. X is the same side. The 14 has to correspond with the 4. Again, this is between the angle that has 2 arcs and the unmarked angle. Here's the angle with 2 arcs and the unmarked angle. So that's the corresponding side. Then Y, of course, has to go with the 10. It's the only thing left. That's between the 2 marked angles. 10 is between the 2 marked angles. So the corresponding sides have to be between identical angles in the 2 figures. So now, which pair of corresponding sides do we know both numbers for? 14 and 4. Very good. So 14 inches is related to 4 inches. I could do 4 over 14. It really does not matter. It's going to work out the same either way. So if I'm trying to find x first, where does x go, top or bottom? It goes on bottom because it is from the same figure as the 4. So it has to go with the 4. What goes above the x? $42. That's the corresponding side from the other figures, the 42. That'll be inches. So now we cross multiply here. 4 times 42 is 168 inches squared. Divided by 14 is going to be 12 inches. So x is 12 inches. Any questions on how I found x? Now to find y, we start out with that same pair. We have the 14 inches and the 4 inches that we know are related. Where is y going to go? Careful. Y is from the same figure as the 14, so y has to go on top now, because it's from the different figure. What goes below the y? The 10 is the corresponding side from the other figure. So we will cross multiply. 14 times 10 is 140. Inches times inches is inches squared. Divided by 4, inches is going to be 35 inches. So y is 35 inches. These are used a lot. One example might be on a map. You have 0.5 inches equals 50 miles. And you have something on the map that measures out 2 3/4 inches, 2.75 inches. Well, you've got 0.5 inches to 2.75 inches. Now the 50 miles goes with the 0.5 inches. Your actual distance, x, is what we're looking for. Cross multiply and divide. 2.75 times 50 divided by 0.5 is going to be, what, 275 miles? So those 2 points on the map are actually 275 miles apart in real life. Sure. Let's take a look at our friend Steve. Steve is getting in trouble again. Steve wants to cut down a tree in his yard. Problem is, his house is there. And his house is only 83 feet from the bottom of the tree. Steve needs to know if he cuts that tree down, if can it reach the house and cause damage? So Steve is going to use our old friend the sun. That tree casts a shadow. Let's say the length of the shadow of that tree is 58 feet. Steve measures his own shadow. Steve himself is exactly 6 feet tall. And his own shadow comes out to be 4.1 feet. So the question is, does the house survive? Well, I want to know how tall the tree is. That's going to be a height H, I'm going to call it, for the height of the tree. So I'm going to compare Steve's height, 6 feet, to the height of his shadow, 4.1 feet. In the other ratio, where does the H go, on top or on bottom? H is the height, so that goes on top. 6 feet is Steve's height, that went on top, so the height of the tree goes on top. The shadow goes on bottom, the 58. So we are going to cross multiply 6 times 58 and divide by 4.1. We get 84.88 feet. So yes, the tree will reach the house. Probably won't do a whole lot of damage because it'll be just the top foot of branches, but might scratch the siding or crack a window. But that's a form of indirect measurement you can use to measure the height. It's a big tree. Will be after he cuts it. Any questions on that? Okay. There are a lot of things, like I said, those similar triangles, similar figures. They don't even have to be just triangles. It can be any figure. There are a lot of things those can be used for. The basis of trigonometry, which we're not going to get into. All of trigonometry is based on the fact that right triangles with right angles, are all very similar. So as long as you know one of the other angles, the other sides have definite ratios in them. So that's what trigonometry is all about. You don't have to have triangles. You can have figures like this. Now I'm going to make it easy on you. I'm just going to tell you those angles are the same and those angles are the same. So you know this is sitting in the same orientation. If I were to ask you to find sides X, Y, and Z here, Do I have a pair of corresponding sides that I know both lengths for? I have the 6 and the 9, right? 6 inches goes to 9 inches. If I'm looking for X, X has to go on bottom. What's going to go on top of it? Okay, it goes with the 12. We will cross multiply and divide here. 9 times 12 divided by 6 tells us that X is 18 inches. We'll use that same ratio. 6 goes to 12, or 6 goes to 9, I should say, to find Y. Y still goes on bottom from the same triangle as the 9. Above it's going to be the 6. Over here. Cross multiply and divide. 9 times 6 divided by 6. Y has to be 9 inches. For Z, we're going to use the same ratio. 6 inches goes to 9 inches. Z is still from the same figure as the 9, so Z goes on bottom. What goes above the Z? 14 inches is its corresponding side. Cross multiply and divide. 9 times 14 divided by 6. We get 21 inches. Is Z. Well, now that we've discussed these similar figures, let's look at something like this. Here's a rectangle that's 2 inches by 5 inches. I'm going to blow it up to make it 6 inches by 15 inches. Are these rectangles similar? Yes, they are. 2 relates to 6 the same way as 5 relates to 15. Sides are just tripled. I can cross multiply here and get the same product. I get 30 here and 30 here. So that works. So the ratio of sides here doesn't matter which side I pick. I'm going to pick the 2 became 6. 2 inches became 6 inches. Both of those can be divided by 2, gives me a 1:3 ratio of sides. Could have done the same with the 5 and the 15. 5 inches becomes 15 inches. Again, both of those divided by 3 gives me divided by 5 gives me a 1:3 ratio of sides. So my ratio of sides is 1:3. What's the area of this figure? 10 inches squared, yes. 5 times 2 or 2 times 5. What's the area of this figure? $15 times 6 will be 90 inches squared. My ratio of areas is 10 square inches to 90 square inches. Both divide by 10 to give me a 1:9 ratio. Ratio of areas is not equal to the ratio of sides. I have a triangle. It's 3 inches by 7 inches. And I blow it up. So 6 inches by 14. Are those similar? Yes, both sides have just been doubled. So my ratio of sides, ratio of lengths, the 3 inches became 6 inches. So that is a 1-to-2 ratio. Could have done the same. The 7 became 14. Areas. The area of this is 3 times 7 divided by 2, or 10.5 inches squared. The area of this one is 6 times 14 divided by 2, or 42 inches squared. The ratio of areas is 10.5, 42. Now to simplify that ratio, I'd get rid of the decimal here. I'd multiply both of them by 2, which gives me 21 to 84. And now both of them divide by 21. Gives me a 1-to-4 ratio of areas. So now we're going to end right here for the first hour of class. We're going to come back and we're going to start talking about that in the second hour.